Have you ever wondered how our subjective experience arises from the complex activity of the brain, and how we might even measure something as elusive as consciousness? Integrated information theory, often referred to as IIT, does possess some emerging empirical support, but it is important to understand that this support is still partial, indirect, and subject to ongoing scientific debate and refinement. Researchers are actively working to test its core predictions through various experimental approaches. The core idea behind IIT is that consciousness is directly related to the amount of integrated information a system can generate, often quantified as phi. This theory proposes that for a system to be conscious, it must have a large repertoire of possible states, and these states must be highly integrated, meaning they cannot be broken down into independent parts. Empirical support for IIT largely depends on finding neural correlates of this integrated information, particularly in conditions where consciousness changes, such as during sleep, anesthesia, or in cases of brain injury. Researchers approach this by looking for brain activity patterns that reflected a system's capacity for integrated information. For example, they might use techniques like transcranial magnetic stimulation, TMS, combined with electroencephalography, EEG, to perturb the brain and then measure how complexly it responds. A highly integrated and differentiated response is hypothesized to indicate a higher level of consciousness. One key experimental measure developed from IIT is the Perturbational Complexity Index, or PCI. This index quantifies the complexity of the brain's EEG response to TMS pulses. Studies using PCI have shown promising results, indicating that values are high in conscious states and significantly lower in deep sleep, anesthesia, and in patients with unresponsive wakefulness syndrome. This suggests that the brain's capacity for integrated information might indeed be a measurable proxy for consciousness. While not definitive proof, these findings provide intriguing evidence aligning with IIT's predictions, particularly concerning how the brain processes information in conscious versus unconscious states. The ongoing research continues to refine methodologies and explore the theory's applicability across a broader range of conscious and altered states, bringing us closer to understanding the fundamental nature of subjective experience.
If you're into this, like, subscribe, and drop a comment.